In this section, we focus on the life story of a key, how it's created, where it lives, who can use it, and when it must be rotated or destroyed. Understanding this life cycle is essential for secure HSMs, PKI, and compliant trust services. Strong cryptographic algorithms are useless if the keys are weakly protected. Attackers rarely break the math. They steal, guess, or mishandle keys. Think of keys as the combination to a vault. If that combination leaks, everything inside is exposed. Throughout this course, we'll keep returning to three themes: how keys are created, how they live and change, and how policies control their use. It helps to think about keys in terms of what they protect, not just by algorithm names. Encryption keys protect confidentiality. They turn readable data into ciphertext and back again. Signing keys protect integrity and non-repudiation. The private key creates a signature. The public key lets anyone verify that nothing changed and who signed it. Authentication keys establish identity, proving it's really me, as in TLS or SSH logins. One crucial rule: never reuse a key for both encryption and signing. Keeping those roles separate limits damage if one key is ever exposed. Modern systems almost never rely on a single key. Instead, they layer keys in a hierarchy. At the center is a master key, usually locked inside an HSM. Its role is to protect other high-value keys, not data directly. One level out, key encryption keys wrap or encrypt data keys. At the edge, data encryption keys handle the actual application or storage data. This structure localizes damage if one key is compromised and supports strong separation of duties. Every cryptographic key goes through a life cycle, just like a user account or server. First, it's generated, ideally by a strong random source or directly inside an HSM. Then it's distributed to the systems that need it, usually over TLS or by wrapping it with another key. Next comes usage. Applications call the key for encryption, decryption, or signing under strict access control. Over time, you rotate keys, archive old ones for compliance, and finally destroy them securely so they can't be recovered. Key security starts at birth. Strong keys come from three ingredients working together. First, a cryptographically secure random number generator, fed by high-quality entropy, makes the key unpredictable. Second, generation happens in a controlled environment like an HSM or KMS, so the key never appears in plain form on random servers. Third, policies enforce approved algorithms and key sizes. At creation time, you also define metadata: what this key is for, who owns it, when it expires, and what usages are allowed. Once keys exist, the priority is keeping them safe at rest and in motion. At rest, avoid hard-coding keys in application code or config files. Keys should live inside a secure boundary, such as an HSM or dedicated key vault, and applications only get references or wrapped keys, never the raw master keys. For distribution and usage, protect every channel with strong encryption and mutual authentication, and log each key operation. Those audit trails later prove who used which key and when. Key rotation is how you evolve a key without breaking everything that depends on it. Think of it as version control for secrets. The old key becomes decrypt only for legacy data, then moves into an archived state so you can still recover if needed. The new key version handles all fresh operations. Rotation can be driven by time schedules, suspected compromise, or major role changes. In parallel, you maintain secure, redundant backups of master keys and key encryption keys. End of life is where many key management failures happen, so we treat it as a first-class stage. Expiry is the planned end. Every key gets a hard stop date, and after that, systems simply refuse to use it. Revocation is the emergency brake. The moment you suspect compromise, you flag the key as untrusted and block it everywhere. Destruction is about erasing all traces: active copies, logs, backups, and any exports or screenshots. The goal is simple: a retired key must never come back to life. Governance is where cryptography meets real-world rules. Policies define which algorithms and key sizes are allowed, and which keys may encrypt versus sign. Schedules specify how often keys rotate and how long data and logs are kept, based on sensitivity. Alignment with standards like NIST, PCI DSS, or GDPR then helps ensure your HSM and PKI choices will stand up to regulators and auditors. Eliminating unilateral control means no single person can misuse cryptographic keys or HSMs on their own. We separate duties between people who operate the system and those who oversee it. One person might manage keys, another administers servers, another defines security policies, and another independently reviews logs and evidence. Enforcement comes from IAM, key management systems, and approval workflows. So sensitive actions require multiple people, are documented, and can be reconstructed later if something goes wrong. Consensus is how we keep the most powerful capabilities under control. Dual control means no single operator can perform a critical action alone, like activating a master key or performing a key ceremony. Two or more people must cooperate in real time. Split knowledge goes further. No one even knows the whole secret. Each person holds only a share, often using Shamir secret sharing, and only combined shares reconstruct the key. Together, these patterns block insider abuse and create strong, auditable governance. When you bring HSMs into real environments, granular permissions become as important as the crypto itself. RBSE answers, what can this role do with keys, while ABAC adds context? Which application, tenant, environment, network, or time of day? Together, they let you encode least privilege rules as policy, not code. Integrated with SSO and MFA, these checks ensure that only the right person, in the right context, can access the right key namespace within each isolated tenant environment. Everything here boils down to one idea. Control your keys, or your security doesn't matter. Use the right key types in a clear hierarchy, protect them in HSMs, and enforce the full lifecycle from generation to destruction. Wrap that with separation of duties, strong policies, and continuous audit, and you're operating securely.